So we're going to continue talking about the fractions, and if you want to compare fractions, there's two ways that you can do it fairly simply. The first way is, if you're comfortable with fractions, you can use just a common denominator. So you can get a common denominator, then compare the numerators, and comparing means like which one's bigger, which one's smaller, if they're equal to, or something like that. So you could get a common denominator, then compare the numerators, or you could also just turn them into decimals and compare the decimals. Those are the two ways to compare fractions. There might be another way. How else could we do this? Any other way is like a version of one of these two ways. So we can compare them by getting a common denominator. You can just multiply by the least common multiple of all of them, maybe, or the greatest common factor. I don't know. You find the GCF, greatest common factor. Yeah. Just get the common denominator. Doesn't have to be the smallest. You just get a common denominator and compare the numerators. So let's do a quick example. So the question is, which one is bigger, 13 out of 43 or 12 out of 42? I can't tell right away. So what I'm going to do, first way, get a common denominator. I can just multiply by 42. I think 43 is a prime number. 42. And then multiply this one by 43. I'm just getting a common denominator. So in this case, this is definitely greater. So that means this is definitely greater. I'm unreducing these. That's all I'm doing. Because, after we unreduce them and make them like have the same denominator, it's as if we're comparing two glasses of water, where I have one glass that's really, really skinny and one glass that's really, really fat. I can't really tell if they're the same or which one has more water or which one has less water until I put them in the same glass. Because when I put them in the same glass, then I can compare the height of the water, and I can figure out which one has more and which one has less. So, I mean, that's the analogy here. Or you could get a common denominator, or we could just get a decimal. If I do 13 divided by 43, I'm doing that in my calculator, that gives me 0.30232558. And then if I do 12 divided by 42, that gives me 0.2857149. So again, this one is bigger, so that is bigger. So those are the two ways to compare fractions. The next thing I want to look at is properties of fractions, and these are shortcuts. If you keep them in your head, dealing with fractions becomes a lot easier. So one of them we already addressed. Actually, you know what? We'll get to that one in a little bit. One property is that if you divide two fractions, you flip the second one over and multiply. Just take the bottom one over, take the bottom one, flip it over, and multiply. That's all you're doing. Some people like the double C. So you're multiplying D times A. That's what I'm doing there. And then on the bottom, you have B times C. It's a double C, backwards C, I guess. So there you go with that. That works the same as if you have 1 over A divided by B. Like if you're dividing 1, that's the same thing as B over A. It's a shortcut. But you could still use the same rule, because 1 over 1 is the same thing as 1. But you could still use the same rule. It's just important to remember that part. And then dividing, I guess we can say dividing by a whole number is the same thing as multiplying by the fraction 1 over that number. So that becomes important. Even if A is a fraction, it's the same thing as multiplying. Multiplying by 1 over A. That would just use something like that. Maybe I should not call it A. So there are some rules with fractions. It's very simple with that. The next thing we're going to get into are percents. And hopefully this will be fairly simple, but oh my goodness. Percents are always out of 100. So if I say 20% of 42 is, the way I can do this is just translate the numbers again. Here at 20%, that's the same thing as 20 over 100. Percent is like how many hundredths. So if I say 20%, that's 20 100ths. Of means multiply. 42, and I can just start to reduce and then see what that equals. And if I just divide by 2, I get 20 times, this is over 1, right? So this would be, what, 21 over 1, and this would be 50. And then maybe reduce this part. I can divide by 10, that goes away, and so I just have back to 42 out of 5, right? Because 21 times 2 is 42. And the 5, that's I can't reduce that. So 20% of 42 is 42 divided by 5. So as a decimal, so you could leave it like this, or as a decimal, you can say 8.4. So either one of those is okay. So 20% of 42 is 8.4. That means if I have 20%, how much left over till I get 100%? Well, that's 80%, right? So if I had 80% 42, that should be the rest. That's 42 minus 8.4, right? Hopefully that makes sense, but if not, that's okay. I think you'll be able to figure out the problems that you have. So this question is a little bit different just because of the wording. It's hopefully you can translate it and then be able to solve it, but it's kind of just complicated in its wording, not really in the math part. So let's piece it together. In this case, it's saying what percent, so your answer should be a percent. And remember, percents are always out of 100. So I'm going to say percent, that's going to be my x. So x over 100. What percent, there we go, of means multiply. 60 is x. Oh wait, I used x. How about we call that a? So what percent x of 60 is a? So I'm going to write down a percent. Remember, a percent is always out of 100. So x is the percent of 60, and then equals a. So in this particular question, we won't be able to get an actual number. We're just going to be able to get x in terms of a. So really all I'm doing is I read the words and set them up. So that's what I did here. And then I'll solve for x, because x is what it's asking me for, what percent. So here, I guess I'll just cross cancel. I can divide by 10. So that goes away and that goes away. So I just have 6 over 10, but I can divide that by 2. So divide by 2, that's a weird division. So I get x times 6 divided by 2 is 3 over 5. And that is going to equal a. And here's another part for fractions. You can multiply by the reciprocal, and that will cancel out. So I'm multiplying by the reciprocal. So x equals 5 over 3 times a, which is the same thing as 5a over 3. So it's saying what percent of 60 is a? It's this percent, which is a weird thing. Like, we don't really know what this means until we actually put in numbers, but it's a really simple way of solving it. You just translate the words. I suppose you could say, like, not translate it into math. You could just put something in there, like what percent of 60 is 30, and then figure out what x is, and then compare it to your multiple choice answers. But this is, I think, easier. You just translate the words and then do the math. There you go.